Hi everyone, and welcome back to the last video on water pollution in the Laurelton Hall AP Environmental video series. So far we've looked at various forms of pollution that we may be familiar with from news stories or previous classes. In this video we're going to look at less familiar sources of water pollution, including solid waste pollution, sediments, thermal pollutants, and even noise. Solid pollutants consist of discarded non-toxic materials from household and industrial use. In other words, garbage. Solid waste can be deliberately dumped into bodies of water or it can accidentally enter waterways due to improper disposal techniques. Regardless of how it gets there, solid waste are a danger to aquatic organisms. Plastic rings can strangle many animals, plastic bags are mistaken for jellyfish and consumed by sea turtles, and degraded plastics are often mistaken for plankton by plankton eaters. Solid waste in the oceans becomes concentrated in the North Pacific Gyre and in a floating mass called the Great Pacific Garbage Patch. The presence of this floating dump, combined with medical waste washing ashore, led the U.S. to curtail ocean dumping in the 1980s, greatly reducing the problem. Sediment pollution is the increased transport of sediments by rivers and streams. Human activities such as construction and plowing cause the increased sediment load. An increase in sediment load causes the water to become murky, cutting down the amount of sunlight available to aquatic plants, thus decreasing system productivity. In addition, sediments can also clog fish gills, hindering respiration. Thermal pollution occurs when human activities cause a substantial change in water temperature. A variety of industries use water for cooling systems and return the heated water to the environment. This can result in thermal shock, in other words, killing temperature-sensitive organisms. Recently, the EPA has taken steps to regulate how much heated water can be returned to natural systems, and industry has invested in cooling towers which release the excess heat into the atmosphere, rather than into the water. Probably the least understood form of water pollution is noise. What we do know about noise pollution is that low-frequency, long-distance communications, such as Navy sonar, have been linked to instances of whales beaching themselves in the Bahamas, the Canary Islands, and the Gulf of California. In an effort to protect the whales, in 2003, a federal judge prohibited the U.S. Navy from installing a network of long-range sonar systems across the ocean floor. Unfortunately, his ruling was basically overturned in 2008 when the U.S. Supreme Court passed a ruling that exempts the Navy from having to follow environmental laws. Smart. As you've seen throughout this video series, the United States is making progress in curbing water pollution. Our two most important laws in this fight are the Clean Water Act and the Safe Drinking Water Act. By the 1960s, water quality in the U.S. was really bad, and I mean really bad. In fact, in 1952, pollution on the Cuyahoga River in Ohio was so bad the river actually caught fire. It was obvious that something needed to be done. So in 1972, a mere 20 years later, the Federal Water Pollution Control Act of 1948 was strengthened and expanded. The main purpose of this law is to support the protection and propagation of fish, shellfish, and wildlife, and recreation in and on the water by maintaining and restoring the chemical, physical, and biological properties of natural waterways. Most importantly, the Clean Water Act issued water quality standards which allowed the EPA to set safety limits on how much pollution could be discharged into surface waters. Sadly, the Clean Water Act makes no provisions to safeguard groundwater supplies. The Safe Drinking Water Act, however, does encompass both surface water and groundwater drinking supplies. Originally passed in 1974 and amended in 1986 and 1996, the law mandates that the EPA set maximum contaminant levels for 77 different elements in our water. These elements include various pathogens, disinfectants, organic chemicals, and inorganic chemicals. Even though both these laws have been subjected to political pressures, they have been overwhelmingly successful in combating water pollution from point source pollutants. However, neither law covers non-point source pollutants such as oily runoff from parking lots or pesticides and fertilizers from suburban lawns. So it's clear that we still have a long way to go. Hopefully in the future, all of our water will be relatively clean and pollutant-free.